Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Adnan bin Abu Bakar. My matrix number is AA190659. I am from section 7 and I'm going to present about lab 4 electro-pneumatic circuit and electro-hydraulic circuit. So the first one, I'm going to present about like activity 1. So this is the circuit that we have to construct, and I already construct for electro-pneumatic and electro-hydraulic circuit. So I'm gonna talk about the simulation. I'm gonna start with electro-pneumatic circuit. So I click the run button, and when I push the push button, current will flow through the limit switch in normally closed condition and will energize the relay K1. And after relay K1 is fully energized, both switch at K1 will close and current can flow through it and will flow through the valve, and the valve will trigger. So I push the button once again. So that is the simulation for electro-pneumatic circuit. So for the electro-hydraulic circuit, the process of the simulation is actually the same. So I'm gonna click the run button and push the push button, and also you can see the current will flow through the limit switch and will flow through the relay K1, and after relay K1 is fully energized, the both switch K1 will close and it will trigger the valve here. And as you can see, when I push the push button here, the cylinder will move downward. And for electro-pneumatic circuit, when I push the push button, the cylinder will move to the right. But the difference is for electro-pneumatic circuit, the cylinder will move faster than the electro-hydraulic circuit. For electro-hydraulic circuit, the cylinder move slower than the electro-pneumatic circuit. So that's it for the simulation. So for observation for lab activity 1, to briefly discuss the function of the two components circled in red below. So the first one is a tank. Tank is container to hold the fluid required for supply system. And the second one is air compressor. It is convert power into potential energy stored in pressurized air. So for question part number 1, describe the difference between electro-pneumatic and electro-hydraulic system. So the difference is the operation is actually remain the same, but the difference between electro-pneumatic and electro-hydraulic is the supply. In electro-pneumatic, the supply is compressed air, while in electro-hydraulic, the supply is a fluid. So for question number 2, describe an industrial application for electro-pneumatic and electro-hydraulic system shown in figure 1. So electro-pneumatic use electrical technology to control the compressed air. Use as a medium, electrical devices such as limit switches, valve and relay are some of the mechanism used. For electro-hydraulic system, in automotive technology has introduced an electro-hydraulic control system, adding to its range valve, actuator and control. The product can be directly mounted to linear or quarter turn spring counter. So for lab activity 2, this is the circuit that I'm gonna construct, and this is the circuit that I've already constructed. So I click the run button over here. So as you can see here, whenever the limit switch operates, it will energize the relay K2 and the switch as K2 will close. When switch K2 and K1 is closed, it will trigger the IM1 valve and it will move the cylinder over here, the actuator over here. So same goes to the IB2. When it is in a closed circuit, the K3 relay will energize and K3 switch will become normally closed and is going to trigger the IM2. So when I click the push button, you can see it's moving and there's a current flow. So when I re-push the push button here, the operation will stop and the cylinder will back to its original position. So for observation number 1, state the name of component IB1 and IB2. So the name of component IB1 and IB2 is the limit switch. Question number 2, briefly discuss the function of IB1 and IB2 in this circuit diagram. So the function of IB1 and IB2 is simply to control the cylinder rod. And question number 3, during simulation, a symbol with an arrow always appear next to the component in the electrical diagram. Discuss what do you understand when you see the symbol. So the symbol is actually represent the current that flow through the circuit. So for question number 1, discuss the importance of component A in an actual application. So the function of this component is to provide the pneumatic system with a well-clear compressed air. The air produced by the air compressor is not clean and regulated. This can cause several problems to the system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zul Nazmi bin Zailani. My metric number is AA191908. Today I want to present about lab activity 3 for lab 4. Okay, first I should develop the electro-pneumatic diagram based on figure 3. Based on this figure in fluid sim software, then I need to screenshot the complete diagram. And also I should do a simple video to explain the operation of the circuits. Then I should answer the observation and the question for this lab activity. So let's see, I explain the operation of the circuit. Okay, this is the electro-pneumatic system that I have built in fluid sim software. Here we can see original position of the electro-pneumatic system. Okay, this one is pneumatic diagram and this one is electrical diagram. Okay, first we run the simulation. Okay, first I explain about the pneumatic diagram. Okay, first when we run the simulation, you can see air flow from the air compressor through the valve and into the inlet port 1 to outlet port 2 and into the cylinder. Okay, air fill in the front of the piston and make the cylinder retract at 1B1. At 1B1 position, so the air in the space behind the piston is released through the exhaust port 5 to 10. So next we look at electrical diagram. So we can see the electrical flows from 24 volt power supply through the inlet port 1 to outlet port 2 and flows straight to the magnetic proximity switch at 1B1. Inside the proximity switch 1B1, there is normally close contact. When the electrical flow, it can cause the magnetic field applied to proximity switch, so the contact will become open, causing no electrical flow through the relay K2. But now we can see the electrical flow through the proximity switch 1B1. Then the coil relay at K2 will energize. So the switch K2 also will change from normally open to normally closed. Okay, next when I press the D10 switch, so we can see the movement of the cylinder extend and retract back for 5 pulses before it return to original position. So the function of D10 switch is to keep the switch position remain unchanged. We can see here D10 switch change from normally open to normally closed. When the 10 switch is pressed, there is no electrical flow through proximity switch 1B1 because the contact inside become normally closed to normally open. Coil relay at K2 is de-energized and electrical flow change to proximity switch 1B2 through input part 1 to output part 4 and it will change the contact from normally open to normally closed because the presence of magnetic field in this area. When it change to normally closed, electrical flow through the coil relay at K3 and it will energize. So switch at K3 also will change from normally open to normally closed, and solenoid at IM2 also will energize. It also help to extend and retract movement of cylinder. So we see the simulation for the second time. Okay, before I forgot, the function of SE push button is to reset the counter of counter relay. So first we push the push button and we can see it reset. Wait, we change this first to normally open first. So we reset it to, so we can see it reset to 5 back. Okay, we do the simulation for the second time to see how it works. So when we push the D10 switch, now we can see the electric flow through the K3 and it will energize K3 coil, and switch at K3 also change. Before I forgot, when we push the D10 button, coil relay at K1 also will energize. So the switch at K1 also change from normally open to normally closed. Okay, that's all from me. Thank you.
Okay, for observation question number 1, tabulate the list of components used in figure 3. Okay, then I list the component that we use in figure 3. Okay, first, compressed air power supply, air service unit, 5/3 way solenoid impulse valve, double acting cylinder, distance rule, electrical connection 24 volt, electrical connection 0 volt, D10 switch, brake switch, relay, magnetic proximity switch, valve solenoid, push button, and relay counter. Next, number 2. Explain the function of S2. The function of push button S2 is reset button. When we push the detent switch, so the counter will count from 0 to 5. So to reset the counter, we should press the S2 push button and it will be 5. Okay, for question number 1, the position of 1B1 and 1B2 in figure 3 is different from figure 2. By referring the component A and B below, both type of practical of 1B1 and 1B2 in figure 3, explain your answer. Okay, the answer is the purpose of this component is also the same, but because of the different component parts are the magnetic proximity switch that work a little differently than limit switch, where component A is a limit switch that can be operated manually. However, for component B, use a magnetic proximity switch that has reed switch that show magnetic attraction, and also we know proximity switch is also performed due to electromagnetic field interference caused by capacitance. From here, we can know that these two types are practically used for 1B1 and 1B2. Okay, that's all from me. Thank you.